everybody, we are doing lesson 11.1 for intermediate algebra. It is a factoring review so we can get our feet wet with doing the YouTube videos. All right, our very first thing for our factoring review is reviewing a greatest common factor. So what does that mean? We are looking for things that are in common. So the greatest common factor means that we use the biggest number from the coefficient. So that's the biggest number that we can divide every single coefficient by. Okay, then we also look for the smallest exponent, but we only use the smallest exponent if every single term has an x. Okay. If there's terms without x's, then we just don't have an x in the greatest common factor. Okay. When we find the greatest common factor, we set it off to the left-hand side, and we end up dividing every single number for the coefficients by that greatest common factor number. For the x's, we would put x to the smallest exponent on the left, and then inside for each term, we still have x's, but we subtract the exponent that we get to remove from the greatest common factor. So let's do a practice. Okay, this is example number 1. We have 8x to the 5th minus 10x cubed. The biggest number that we can divide 8 and 10 both by is a 2. So we put 2 for the greatest common factor out here. Next, we look for what is the smallest exponent as long as every single term has an x. So both terms have x's, so we're going to put x to the, so we compare 5 and 3, 3 is smaller. So 2x cubed is our greatest common factor. Now we're not just looking for the greatest common factor, we want to actually factor that out. So our goal is to undistribute. Okay, distributing means multiplying whatever's outside times whatever's inside. And with the x's, you would add your exponents together. So we're going to do the opposite of that. We are undistributing. So we will divide our coefficients by the greatest common factor, and we'll subtract our exponents. So 8 divided by 2 is 4. Then we've still got an x, because 5 minus 3 is a 2. Okay, second term. We have a negative 10. Negative 10 divided by 2 is negative 5. And then we would have an x here, except 3 minus 3 is 0. So we have 0 x's left over right there. We always at this point look to see if whatever's inside the parentheses will factor any further. It happens that we cannot factor this problem any further, so this is our answer. Okay. The second thing we're going to review today is difference of squares. So the difference of squares, we need perfect squares. Okay. So the pattern is that we have the subtraction of two perfect squares. So a perfect square minus a perfect square. So that's what the PS stands for. Okay, perfect squares are things like 1, 4, 9, 16, 25, anything that when you take the square root, you get a whole number. So let's review what that would end up looking like. The pattern for factoring is that we have two sets of parentheses that are multiplied together. So this is what our answers will look like. We will have one plus in the middle and one minus in the middle, because this term times this term, a positive times a negative, has to equal this last term, which is negative. And then we take the first perfect square and we take the square root. Its square roots will go here and here in the first position, because that perfect square was first. And our second perfect square, when we take the square root of it, its square roots will go in the second positions. All right, so these two sets of parentheses will look identical, except one will have a plus and one will have a minus. It doesn't matter which one's which. All right, so let's look at example number 2. We have 100x squared minus 49. 100 and 49 are both perfect squares. X squared is also a perfect square because it's got that 2 exponent. And then there is a minus in between, so perfect square minus perfect square. This problem is really nice because it takes one step to do. We know that we're going to have two sets of parentheses multiplied together. One gets a plus, one gets a minus. Then let's take that first perfect square, which is 100x squared. The square root of 100 is 10, but the square root of 100x squared is 10x. So we put 10x in the first position on both factors. Okay, second perfect square is 49. The square root of 49 is 7. So 7 goes in the second position on both of those factors. So our answer is 10x plus 7 times 10x minus 7. Third review is factoring trinomials. So first off, what is a trinomial? A trinomial has 3 separate terms. Okay. We always look and see if there's a greatest common factor first, because that could make our problem a lot easier. Sometimes it works, sometimes it doesn't. Okay. To factor any trinomial, we multiply together the first term times the last term, just the coefficients, the numbers. Okay. From that number that we get, we make a chart and we make our signs. Okay, then we split the middle term. There's other processes that you can do instead of split the middle, but this is the one that we've been focusing on the most. After you split the middle, you find greatest common factors, GCFs, for your first 2 terms and for your last 2 terms. So that's that factoring by grouping. And then our answer step is going to look like parentheses times parentheses. And inside each set of those parentheses, there's going to be 2 terms. Okay, so let's take a look at example 3. We do have 3 terms. Let's multiply together the first term times the last term and set that on top of a factor chart. So 2 times negative 20 is negative 40. Okay, factors of 40, 1 and 40, 2 and 20, 3 doesn't go into 40, 4 and 10, 5 and 8, 6 doesn't go into 40, 7 doesn't go into 40, and then 8 would be our next number, which we already have. So we have found all of the factors of 40. Okay, let's do the signs now. Okay, whatever the middle sign is, the sign of B, that's going to be the sign of our big column. So negative 3 means that we'll have a negative 40, negative 20, negative 10, negative 8. Okay, so we know the sign of the second column. We need the sign of the first column. Okay, our first column is currently positive. Let's see if that works out. Our top sign is negative. That means we need one of each sign. We've got one positive and one negative column, so that's perfect. Our 2 numbers have to add up to get negative 3. So we compare each one of these rows and find that 5 and negative 8 add up to negative 3. Okay. So we're going to take that middle term, which is negative 3x, and split it up into plus 5x minus 8x. And then we'll bring down the first term, 2x squared, and our last term, negative 20. And at this point, we're totally done with the chart, so I'm going to cover that up. Okay, so here's our focus. We have 2 terms here, and we have 2 terms here. We want to find the greatest common factor, just like we did in example 1. So what is the greatest common factor between 2x squared and 5x? There's no number besides 1 that goes into 2 and 5, but we do have an x in common in both of those. So x is our greatest common factor there. Let's do greatest common factor for the other set. Negative 8x minus 20. Well, our first term is negative, so negative. 8 and 20, 4 is the biggest number that goes into both of those. There's not an x in our last term, so x is not common. All right, so x was the GCF from the first set, negative 4 is the GCF from the second set, and let's actually divide those out. So 2x squared divided by x is 2x. 5x divided by x is 5. Second set, negative 8x divided by negative 4 is 2x. Negative 20 divided by negative 4 is positive 5. And at this point, we double check. Both of our sets of parentheses match. That's perfect. So we are ready for that answer step. Remember that our answer looks like parentheses times parentheses. One set of parentheses will be whatever matches, so that's the 2x plus 5. And the other set of parentheses comes from those GCFs, those outside numbers, so x minus 4. Okay, The next thing we're going to talk about is the quick factor. Quick factoring is only usable when we have a trinomial, which again is 3 terms. Okay. So a trinomial looks like ax squared plus bx plus c. It's got to be the x squared. If this is like an x cubed, this is not going to work. Okay. If a equals 1, then this problem right here really looks like x squared plus bx plus c, and we can use the shortcut method or quick factoring instead of doing all of that work that we did in example 3. So this is going to go a lot faster. Okay. Our answer on this problem, on number 4, is going to be 2 sets of parentheses multiplied together. Just like on example 3, 2 sets of parentheses. But this problem is going to go faster because this says 1x squared instead of another number, x squared. Okay. So when we multiply together 1 times 12, we get 12. You can make a chart for this, or if you figure out your numbers without making a chart, that saves you some time. Okay, we are still looking for the set of numbers that adds up to get this middle guy. Okay, our middle is a positive number, so that means that our big numbers are positive. And if the top number up here is positive, that means that your signs are going to be the same. So our 12 and our 1 are both going to be positive, both those columns. Okay, we're looking for the 2 numbers that add up to 7, which is 3 and 4. Both positive, like I said. Since this first one is just x squared, our first terms in both parentheses are going to be x. And then we get to just plop the 3 and the 4, 8 plus 3 and 8 plus 4, straight into those parentheses, and that is our answer. So the quick version of this is, what are the 2 numbers that add up to your middle number and multiply to your last number? Add to the middle, multiply to get last number. All right, let's look at number 5. X squared plus 3x minus 18. Let's see if we can do this without making a chart. Okay, x squared means that our parentheses will both start with an x. Okay, the fact that our middle term is positive means that our big term has to be positive. And since 18 is negative, that means our signs have to be different. So since we have 1 positive, we need 1 negative. Okay, so different signs, that's the big one. Okay, what 2 numbers add up to 3 and multiply to get negative 18? Looks like 3 and 6. Negative 3 times 6 is negative 18. Negative 3 plus 6 is 3. So those are our factors. And last, we have x squared plus 2x minus 24. Again, we can do the shortcut because we've got 3 terms that start with an x squared. So x. Okay, similar to the last problem, our big number is going to be positive because it matches the middle sign. And our signs have to be different because this last one is negative, so here's another negative. All right, 2 numbers that add to 2 and multiply to get negative 24 will be negative 4 and positive 6. And that is our answer. All right, available on Google Classroom is your assignment, which is 11.1. Okay, here's the problems in case you don't have great access to Google Classroom right now. All right, let me know if you have any trouble with these, and I can help you out.